Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss the problems that are related to the addressing modes. So, the addressing mode is used to specify where the operand is available in the memory. Variety of addressing modes are available, and here in this video, the practice problems related to the addressing modes can be discussed. The first problem statement is a two-word instruction is stored in memory at an address designated by the symbol W, and the memory is storing a two-word instruction, and it is stored in the memory at an address designated by the symbol W. The address field of the instruction is designated by the symbol Y. The operand used during the execution of the instruction is stored at an address symbolized by Z. The operand is available at Z. An index register contains the value X. State how Z is calculated from the other addresses if the addressing mode of the instruction is direct addressing mode, indirect addressing mode, relative addressing mode, indexed addressing mode. So here the instruction is stored at an address of W, and it is a two-word instruction, and the address field can be designated with the symbol Y, and the operand is available at the symbol Z, and the index register value is designated with capital X. So Z is the effective address where the actual operand is available. In case of direct addressing mode, what is the value that is specified by the address field? That is at that location of the memory, the operand can be available. So here Y is the address field that is specified in the instruction. So the address specified is the Y. At that location, Y location itself, the operand can be available in case of direct addressing mode. So here W can be used to represent the opcode W plus 1, where the actual address of the instruction can be specified. Next instruction is at W plus 2. Why? Because it is a two-word instruction. Z is the operand. So in case of direct addressing mode, what is the Y? The location that is specified, there itself the operand can be available. Next, in case of indirect mode, while fetching the operand, the Y location of the memory can contain the effective address of the operand. For example, if the Y value is 100 location, again one more memory cycle has to be required to fetch the actual operand in case of indirect addressing mode, so that the address of 100 at that memory location itself, the operand can be available. So that's why in the indirect addressing mode, Z is equal to M, that is location of Y. So two memory cycles are required to fetch the actual operand in case of indirect addressing mode. Next, relative addressing mode is how far it has to be loaded from the instruction. So the address that is specified, and from that the next instruction can be located from W plus 2. Why? Because it is a two-word memory instructions. So here the instruction is stored in the two words, so W plus 2 locations can be moved in order to fetch the operand. In case of indexed addressing mode, the address field that is specified in the instruction Y plus index register value can be added. So here index register value is X. So Z is equal to Y plus X. So in this way, the effective address of the operand can be evaluated in different addressing modes like direct, indirect, relative and indexed. Next problem statement is a relative mode branch type of instruction is stored in memory at an address equivalent to decimal 750. The branch is made to an address equivalent to decimal 500. So, what should be the value of the relative address field of the instruction in decimal? So, here the first question is related to the relative addressing mode. The second question is determine the relative address value in the binary using 12 bits. Next, third bit is determine the binary value of the PC after the fetch phase and calculate the binary value of 500. Then show that the binary value in PC plus the relative address calculated in part B is equal to the binary value of 500. So, relative address has to be calculated here with 500 minus 751. So, minus 251. So, 251 has to be represented the equivalent binary value of 251. But it is a minus 251. The sign bit can be the 1 in case of minus to represent the minus 251. The program counter value can be the 751. So, the binary equivalent of 751 is 00101110 ones. And binary equivalent of 500 is 000510100. And the PC value of this and the relative address minus 251 has to be added by using the 2's complement addition. So, the effective address is 500 which is equivalent to the binary equivalent of the 500. Next, how many times does the control unit refer to memory when it fetches and executes an indirect addressing mode instruction if the instruction is a computational type requiring an operand from the memory? Second category of instruction is a branch type. So, the indirect addressing mode generally requires 2 memory cycles. So, in the instruction general format has to be specified the addressing mode. The next field can specify the opcode. Next, the address. In case of indirect address, I value can be the 1. So, in this case, what is the address specified at the instruction is used to calculate the effective address of the operand. For example, if you specify here address as 100, in the memory at the 100 location, what is the value that is stored? This is the effective address of the operand. So, one more memory cycle can be required to fetch the actual operand. So, at the 400 location, the operand can be available. So, assuming one word per instruction are the operand, in case of computational instructions, fetch the instruction, fetch the effective address, fetch operand. So, 3 memory references can be required. So, here the instruction has to be stored in this format in the instruction register. For this, 1 memory cycle, and to traverse to the address specified, that is another second memory cycle. And what is the location that is specified at the address of the instruction register? This requires the third memory cycle in case of computational instruction. In case of branch instruction, fetch the instruction, fetch effective address and transfer to PC. Only 2 memory references can be required. So here fetching the instruction and calculating the effective address and moving the the execution of the program with the help of branch instruction. That's why the PC value must be updated. So 2 memory references in case of branch type of instruction. Next is, an instruction is stored at location 300 with its address field at the location 301. Instruction is stored at 300 location and address location is 301. The address field has the value 400. A processor register R1 contains the number 200. Evaluate the effective address. If the addressing mode of the instruction is, the first case is direct addressing mode, the second case is immediate addressing mode, third one relative addressing mode, fourth one register indirect addressing mode, fifth one index with R1 as index register. So here at the location 300, the opcode or instruction is available. At 301, the address is specified the value 400. 302 location, the next instruction, and a register R1 containing the value 200. So in case of direct addressing mode, whatever address that is specified in the instruction, at that only the operand is available. So at the 301 location, 400 value is available. In case of immediate addressing mode, immediately what is the next instruction that has to be specified in the instruction address field is the 301. So it is address field at the location 301. So immediate address is the 301. So in case of that, the 301 is the address. In case of relative address, the next address has to be added with the address of the 400. So here the 400 plus 302, 702 is the relative address. In case of register indirect address, what is the value that is specified in the register is the 200. Next, in case of indexed address, the address field plus the register value can be combined. It can be 600. Next problem statement. Match each of the high-level language statements given on the left-hand side with the most natural addressing mode from those listed on right-hand side. So here, what is the addressing mode that is specified in case of the programming languages while assigning array indexes? Next, the second one is the looping structure. The third case is a pointer assignment. So here array has to be, the cells has to be fetched and can be used in the computation with the help of indexing. So here in the array processing, the indexed addressing mode can be used. The second case is while looping structure and loop incrementation, loop variable incrementation can be automatically performed. So the second looping statement, the appropriate addressing mode is auto increment addressing mode. The third one is declaring a pointer variable, and assigning a pointer value to the variable. So it is an indirect addressing. So the matching can be for the first variable, for the first indexing type, it is an indexed addressing mode. For the one, it should be the indexed addressing mode. For the looping, it can be auto increment mode. And for pointer variable, it is indirect addressing mode. So C is the appropriate answer. Next, The most appropriate matching for the following pairs is. So here column 1 is indirect addressing, second one is immediate addressing, third one auto decrement addressing. So in case of loops, generally the auto decrement can be used. So here for the X, indirect addressing mode. For the X, the indirect addressing mode can use the pointers. Why? Because pointer is storing address of another memory location. So for the X indirect addressing, pointers can be the appropriate matching. Next, for immediate addressing, constants can be the mapping. The value can be immediately available. For auto decrement addressing, loops are the best programming construct. So here for X is equal to 2, Y is equal to 3, Z is 1. This is the appropriate matching. So C is the correct answer. Next, in the absolute addressing mode, the operand is inside the instruction. The address of the operand is inside the instruction. The register containing the address of the operand is specified inside the instruction. The location of the operand is implicit. So here the address of the operand is specified inside the instruction. So here in the instruction itself, after opcode, the address of the operand must be specified inside the instruction in case of absolute addressing mode. Next, which of the following addressing modes are suitable for program relocation at runtime? The first one is absolute addressing. Second one is base addressing. Third one is relative addressing. Fourth one is indirect addressing. So here the first option is 1 and 4 combination. Second option is 1 and 2 combination. Third address is 2 and 3 combination. Fourth option is 1, 2 and 4 combination. So here option C is the correct one, 2 and 3. Why? Because in the base addressing, base register value has to be added to the actual address. And in case of relative addressing also, the how much for the operand address has to be taken place. So base addressing and relative addressing generally used to point to the program relocation at the execution time of the program. Next problem statement is, what is the most appropriate match for the items in the first column with the items in the second column? So the column 1 is indirect addressing. Second one is indexed addressing. Third one is base register addressing. Column 2 options are array implementation, writing relocatable code. Third one is passing array as parameter. So here, while indirect addressing mode, passing the array as the parameter is the correct option. And for indexed addressing mode, array implementation is the correct option. Array elements can be fetched and can be used in computation with the indexing mechanism. And base register addressing is used for writing the relocatable code. So here X3, Y1, Z2, A is the correct option. Next problem statement. Which of the following addressing modes permits relocation without any change whatsoever in the code? So here the first option is indirect addressing. Second one is indexed addressing. Third one is base register addressing. Fourth one PC relative addressing. So the relocatable code can be easily achievable with the base and relative addressing mode. So base register addressing can be more appropriate to permit relocatable without any change in the code. So C is the correct answer. Next problem statement. Consider a 3-word machine instruction. Add A @R0, comma @B. The first operand is destination. A R0 uses indexed addressing mode with R0 as the index register. The second operand is the source, that is the @B. So the instruction can have this is the source and A R0 is the destination. So A and B are memory addresses residing at the second and third words respectively. So the first word of the instruction specifies the opcode, the index register designation and the source and destination addressing modes. During execution of add instruction, the two operands are added and stored in the destination. The number of memory cycles needed during the execution cycle of the instruction is the first one 3, second one 4, third option is 5, fourth option is 6. So here we have to fetch first the operand. It uses index addressing mode. So A within the square brackets we have to specify R0. So here thus the memory cycle can use it to fetch the operand. So it requires one memory cycle. For fetching the second operand, it uses indirect addressing mode. For indirect addressing mode, 2 memory cycles can be required. After fetching the 2 operand, the operand will be added and result is stored back in the memory. So it requires the 1 memory cycle. So 1 plus 2 plus 1 total 4 memory cycles can be required to execute the instruction. Next problem statement is, consider a hypothetical processor with an instruction of type LWR1, 20R2, which during execution reads 32-bit word from memory and stores it in the 32-bit register R1. The effective address of the memory location is obtained by addition of a constant 20 and the content of register R2. Which of the following best reflects the addressing mode implemented by this instruction for operand in memory? First one, immediate addressing. Second one, register addressing. Third one, register indirect scaled addressing. Fourth one, base indexed addressing. So here the base register value can be used for indexing. So clearly the instruction uses the base indexed addressing mode. So option D is the answer. So here from the base register the indirect addressing of the register R2 can be used. So it is a base indexed addressing mode. Next problem. Give an example of a RISC-1 instructions that will perform the following operations. First option is decrement a register. Second option, complement a register. Third one, negate a register. Next one, clear a register to 0. Next, divide a signed number by 4. Next, no operation. So how the RISC instruction can be used? So here decrement a register can has to be used, subtract the R22. Here the one value can be given directly with the hash 1 and comma R22. So the register R22 value can be used to -1 and the result can be stored again in register R22. So register R2 value can has to be subtracted by 1. Next, for complement operation, XOR is the mnemonic. So XOR, so R22 hash -1 R22. So here XOR after with all ones that are stored in the content of R2 XORed and that result is stored in the R22. Next, negate a resistor. So here 0 minus the value of R22. So here subtract R0, R22, R22. So which can has to be implement the RTL, R22 resulting with 0 minus R22 which will result in negation operation. Clear a resistor. So here add R0 to R0 and R22. So in the R22 0 plus 0 it has to be store the result in the R22. Next operation is divide a signed number by 4 and no operation can has to be implemented with R and also SLA to shift left. Write the RISC-1 instruction in assembly language that will cause a jump to address 3200 if the Z0 status bit is equal to 1. The first option is using immediate mode, using a relative address mode. The PC address is at 3400. So jump to that location so that the PC address can has to be updated into 0 plus 3200 and next it has to jump to PR Z comma minus 200 so that the value of the PC can be updated with 3400 plus minus 200. Write procedure for reading from and writing to a FIFO queue using a 2 address format in conjunction with indirect addressing mode and relative addressing mode. So reloading the load in the redirect addressing mode with the register value R1 and R2 and increment the R1. While writing that we have to store the data from the R2 and increment the R2 value. So if you have a fixed base register call of branch, then the branch can has to be move this temporary data and branch location can has to be used as an index of offset to store the temporary branching location. During writing, this offset can be used to point to the specific memory location. So rewrite the following sequence of code using the register and register different addressing modes. So load R1 200, add R3 R2 10 and R3 R2 @R2. So load operation, the immediate addressing mode with the help of hash and with the parenthesis register deferred and hash, the 2 instructions registers can has to be used here and add in the above sequence with the 3 register reference addressing modes. An array of 2 integers is placed in memory starting with address 100. Show how to increment the element of the array using displacement addressing. The memory is byte addressable. So here loading the operands first, next performing the add, storing those value And the second word has to be pointed with this for displacement. An integer is stored somewhere in the memory. A pointer to this integer is at address 200. Use memory indirect addressing to increment the number. So the relation between pointer and the number is stored. Pointer is used to store the address of next memory location, and it can be shown here with the help of @. If the base address is in a register, as the most of the machine requires, machines that support this addressing mode, load R1, 200, load R2, 1, add with 3 addressing mode and store the result. So how many memory accesses require the following instructions? So here, suppose every instruction is one word long as well as every address. So here add R1, R2, R3 requires only one memory access. The operands are available at the registers and the result is stored. And at the second instruction, it required 2 memory cycles. Instead of it is an indirect addressing. The R3 is indirect addressing. In case of third one, 3 memory cycles can be required. An array of 2 integers, 32 bits, is placed in memory starting at the address 100. Show how to increment the elements of the array using index addressing. So here with the base value of 100, it is starting. So the first index of the array can be pointed. Next, the index can be incremented by using the hash index to point to the next index location. So in this video, I have discussed the problems based on the addressing modes. For this, I have used the reference of Computer System Architecture, a textbook by Maurice Mano. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.